A very good day to my lecturer and fellow friends. We are from Group 5. In this video, we will present our concept for the major project, which is a device to assist bedridden patients. So our group consists of 4 members, which is myself, Piragalathan Thirunavukkarasu, Aznur Haqimmi bin Azhar, Hor Zhi Wei, and Mohammad Harith Aqil bin Mohammad Sabri. So these are the content for our video. We will start off with customer needs, then product design specification, morphology chart, the final design concept by each group member, scoring, and finally the chosen final design concept. So these are the information about bedridden patient gathered in order to conclude the customer needs. So first of all, let's look at who are the bedridden patients. Bedridden patients are usually elderly people or patients, younger patients suffering from injuries or diseases. So the main problem with them is they couldn't move a major part of their body, such as the upper part or the parts below their hip or their limbs. In some cases, they cannot move even a single part of their body. So they have to stay on the bed most of the time. So what are the causes of this situation? So the first reason is elderly health issues. So this is common among elderly people, usually those who are aged 80 and above, because their body starts losing their function and they become weaker. So however, it still depends on their lifestyle. So the second common reason is accidents. So usually road accidents or electric shocks causes this situation. Uh, this is because their parts like their spinal cord or their brains are injured. So usually if those parts are injured, it will cause them to become paralyzed and they become bedridden. Or if there are any fractures, they become temporarily or permanently bedridden. So the third common reason is diseases. So the diseases like severe stroke, or cancer, and motor neuron disease usually affects nerves in major part of the body, which causes it to lose function, and this causes them to become not able to move the major part of their body. So there are many complications caused by this situation to the bedridden patient. So the common one is difficulties to carry out their daily activities such as eating or disposing their waste. So they couldn't eat. They need someone to feed them since they cannot move their hands and some couldn't move their lips or their mouth, and they need someone to help them to even to urinate and to defecate. So the second problem is immobility. So as stated earlier, bedridden patients cannot move anywhere. So they suffer to even do simple activities such as lifting their upper body to come to a sitting position, and they cannot reach out to take things placed nearby them. So these are some common problems. And the next problem is bed sores, because a bedridden patient uh, lying on the bed for a long period of time, and this puts lots of pressure on their skin, which causes bed sores. And next problem is infections. So common infections among bedridden patients are urinary tract infections. This is usually because a urinary catheter is inserted in the bladder of the patient to help them to urinate, and in some cases this causes infections in their bladder. So there are other health issues caused by this situation, such as pneumonia. Pneumonia is because the muscles of bedridden patients are not always moving to remove excess water from their body. So all the fluid builds up in their lungs, and this causes pneumonia. So problems such as constipation and insomnia are also problems due to the lack of movement of muscles among bedridden patients. So due to all these complications, the bedridden patient needs someone like a caregiver to assist them almost 24 hours. So this causes a huge burden to both caregiver and the bedridden patient. So the customer need will be to solve some of the complications here to reduce the burden of the caregiver and the bedridden patient, to make it easier for a bedridden patient to overcome some of the complications listed here.
Assalamualaikum and hello to the doctor and audience. My name is Mohammad Aqil Harith bin Mohammad Sabri. Today, I'm going to share with you guys the product design specification of our device. Firstly, we go to the function. The function of our device is to easily change patient position from lying to sitting less or equal 30 degrees. So basically, this device just cover for upper body patient from hips to the head. And then other advantages like reduce caregiver burden. So by that, caregiver no need to use their physical strength to change patient position. And then it will reduce risk of patient such as atrophy, muscle atrophy, pneumonia, and blood clot. And then we go to the customer specification, caregiver. This device just need one person to operate or set up the device, so it will become easier. And then for bedridden patient, the age of bedridden patient from adults to the age of 18 years old, and of course is suitable for both male and female patient. And then for hygiene, first material is waterproof, so that easy to be clean. And then it has breathable material for quick drying and can avoid bacteria. Next we go to preferred material. The material we prefer is polyvinyl chloride PVC. Why we choose this material? Because it's durable, able to withstand heat, pressure, and damage, and prevent irritation or allergy to sensitive skin. So it's good for our device and suitable for bedridden patient. And second one is layer on breathable material. Next we go to device measurement. This device within the standard twin mattress, 96.52 centimeter times 203.2 centimeter. And then the length is less or equal 100 centimeter, width less or equal 96 centimeter, and then the mass less or equal 20 kilogram. Here we have the data about anthropometric data. This data show the approximately 100 centimeter for upper body, and the patient weight is not more than 110 kilogram. And then here we see anthropometric dimension, eyes height, shoulder height, elbow height, and so on. I think that's all for me. Thank you.
Next, I'm going to explain about the morphology chart. There are 6 sub-functions in this morphology chart, namely attach or mount to bed, raise and lower the device, move or carry the device, fold the device, hold the patient, and motion control. There are few solutions for each sub-function. For the first sub-function, there are 4 solutions which are Velcro, belt, ripples or clippers, and screw. The second sub-function raise and lower the device have 5 solutions. Worm gear mechanism, jack, inflatable materials, pulley or hydraulic, and gear system can be used. In order to move or carry the device, wheels and handle can be used. For the fourth sub-function, there are 4 solutions, which are plastic hinge, nut and bolt, heavy-duty hinge, and ball-bearing hinge. In order to hold the patient, belt and elastic band can be used. For the last sub-function, there are 4 solutions which are buttons, sensor, joysticks, and manual. Next is concept design. There are 4 concept design and I will going to explain about the concept design 1. This is an overall design for the concept design 1 and this is a bed stat for a bedridden patient. This bed stat has 2 layers. The first layer of bed stat can be divided into 2 parts, which is upper part and lower part. Upper part of bed stat can be moved and the lower part of first layer of bed stat is fixed. The second layer of bed stat is also fixed. This first layer of bed stat is connected with hinges. There are 2 metal plates. The first metal plate is connected to the first layer of bed stat and it can be moved. This second metal plate is fixed at the second layer of bed stat. There's a gear system used to raise and lower the device. There is a heavy duty hinges here and there's a small metal rod here and the mechanical sensor is attached below the gear system and there's a motor to control the gear system. The small metal rod here is attached here and is used to touch the mechanical sensor when the bed stat raised to a particular level. This mechanical sensor, which is attached below the gear system, is used so that the device can stop while the bed stat raised to the level and the small metal rod touch the sensor. Hinges are used so that the upper part of upper layer of bed stat can raise to 80 degrees and switch is used to on and off to raise and lower the device. The motor is connected with 2 metal rods. This one is attached to the gear system and the lower one is to support its weight and it is attached to this metal plate. This is the heavy duty hinges, the type of heavy duty hinges used in order to connect this metal plate to this metal plate which is attached to the upper layer of metal plate. That's all for this concept design 1.
This is my concept design. My idea is that the device has an inflatable material which is used to inflate or deflate when needed. The way that this device is installed is by putting it on the mattress. It has a thin layer of inflatable material and a velcro at the side. The purpose of the velcro is to put the elastic strap in place when not in use. This device comes with 2 elastic straps that holds down the patient during the inflation of the bag. The strap can be used in any way that brings comfortability to the patient. The device comes along with a small air tank that needs to be replaced in every 2 years. There are buttons to allow the air to flow inside the bag. This air tank is the source of air for the inflation of the device. This device also consists of a separate hole for deflation.
My name is Mohammad Aqil Harith bin Mohammad Sabri, and here is my concept design. Basically, I'm used Velcro on this device to attach to the bag. Why I choose this because it has great strength and is low maintenance. And then here we can see the inflatable material and here also, but it just has it from this until this because this device just cover for upper body patient only. The inflatable material is very good because it allow for better blood circulation, pressure relief and refreshing sleep for patient. And then this belt is used for hold the patient here. And then this electric plug-in, we use electric plug-in using this plug to supply electric current to the device. And then small here we have the button to control the motion of the device. And also here we have the handle to move or carry the device. And then we have hanger to fold the device, because actually this device, when we off this device from this belt, we can fold it. I think that's all for me. Thank you.
Hello everyone. So this is my design concept for the bedridden patient assisting device. So as stated in the PDS, the main function is to lift the patient's upper body or to enable them to sit. So this is my overall design. So the design consists of one backrest here, a hydraulic pump and two hydraulic cylinders, and one set of frames. So the backrest is clearly visible here, and the hydraulic pump system is shown here. So basically how the hydraulic system operates is there is a lever here for the operating person to pump. So before pumping the hydraulic pump, they have to close the valve here. There is a small valve here which they have to close, and then when they pump it, the piston here of both of the cylinders will be pushed outwards, and the hydraulic cylinder will elongate. It will become longer, and then once this uh, valve is opened, the hydraulic fluid inside will be released, and the piston will be pushed back inwards, and the hydraulic cylinder will become short again. It will return to the original position. So basically, when this hydraulic system and this frame is fixed together, how it operates is shown here. So this is the original position of the frame. When it is pumped, the hydraulic cylinder will elongate, and the end of the frame will be raised upwards, which causes it to become straight like this. So the angle is not more than 80 degrees, and once the valve is released, it will return to the original position like this. This is basically how the device operates. So when the frame is raised upwards, the backrest is bring upwards. So the backrest is where the patient's upper body is placed, and this is the orthographic view of the backrest. It is basically curved in the middle. So this is basically how my design works.
Our device can be compared to the existing device in market, which is called datum, and here shows the picture of the datum. And now I will be talking about the scoring of concept design. So each member is assigned to a number that is used as reference to evaluate their marks. In our scoring, they consist of a few criteria that can be seen in the table. For example, the time taken to perform tasks, number of steps needed to operate, stability, smoothness, and etc. So these criteria are the factors of evaluation that is done by every member. The score is ranging from -2, -1, 0, 1, and 2. And each number represents from worst, bad, good, and best. And 0 means that it is mediocre. To get the marks, the score is multiplied by the weightage. Then the total score is added up. Finally, the highest total score is chosen as the final design for our device. From the table of scoring, we can see that concept 4 has the highest total mark. This means that concept 4 is chosen to be our final design.
Hi everyone. Since concept 4 got the highest mark after the scoring process, it is chosen to be the final design of group 5. However, a modification is made to the design before finalizing it, and the modification is made by choosing one criteria in the scoring part to be improved in the design. So that criteria is the number of steps needed to operate the device. In order to reduce the steps to activate the device, we have replaced the manual hydraulic pump in the device by an electrical hydraulic pump. Now let's zoom into each part of the design. So this is the hydraulic system in the device. There are two cylinders connected in a parallel way. So this is called synchronized hydraulic cylinders. And as you can see, there is a electrical hydraulic pump here. in order to pump the oil into both of the cylinders. So there is a pressure gauge here to show the pressure of the hydraulic pressure of the device, and there are two buttons here. One button is to turn the device on and off, and one more is to increase the hydraulic pressure in the device. When the pressure button is pressed, the hydraulic pressure in the device increases, and both of the pistons in these cylinders will be pushed out of the cylinder, and this causes the cylinder to elongate. And when the button is released, both of this cylinder is pushed back into the cylinder, and it returns to its original length. So there are four wheels in this machine and one handle. The handle is to carry the machine to anywhere, and the wheels make it easier to be moved to a different position. Now let's look at the next part of it. So this is the frame of the device, and this part is where the backrest will be placed. So there are functions for each part of this frame. So as shown here, this is to support the backrest because this is placed on the center part of the backrest, and both of these part is to elevate the backrest to bring it upwards and down. And as you can see here, there are two parts down here, and both of these parts are to be mounted to both sides of the bed, so that this device can be fixed on the specific position on the bed, which is the upper side of the bed, because there is where the patient's upper body will be placed. Both of the hydraulic cylinders will be fixed on this device to enable it to function. So now let's look at the next part of the design. This is the side view of roughly how the device looks when the hydraulic cylinder is fixed to the frame, and how it operated is shown here. When the pressure increases, the cylinder will become long, and this part of the frame will be elevated upwards. So when the button is released, the pressure will decrease, and this part will be returned to its original position because the piston is pushed back into the cylinder, and the cylinder becomes short again. Now let's look at the orthographic view of the backrest. So this is how the backrest will look from the top, from the front, and at the side. So the middle part of the backrest is basically curved. The curve is to enable the patient to lie comfortably on the backrest with good stability. The sides of both of these parts are where the frame will be fixed to the backrest. Now let's look at the material of the backrest. So the material is basically made of PVC. Since PVC is a durable and strong material that is able to withstand heat or pressure, and PVC is also an environmentally friendly material, and it can prevent uh, irritation or allergy to sensitive skin. Besides, this device is also covered with a layer of breathable fabric. So there are two reasons this material is used to cover the backrest. First one is because it is soft, and it will be comfortable for the patient to stay on it. And the second reason is because it is a quick dry material, and it can prevent bacteria from breeding on it. So this is a brief explanation of the final design of Group 5. Thank you very much for listening.